Okay, so this one's a little bit tricky, and you can do it by just looking at the numbers, but I find it actually much easier if you draw the Dalton models of this, because then you can see the overview. So if we're looking at our unbalanced chemical equation, we have ammonia, which is NH3 plus nitric oxide, NO2, yields nitrogen gas, N2 plus water, H2O. So if we're looking at this, this would basically be our unbalanced chemical equation. So if we're looking at our unbalanced chemical equation, we can see on the reactant side that we have 2 nitrogens. So our reactants, we'd have 2. Our hydrogens, we have 3 hydrogens, so that's a 3. And our oxygens, we have 2. And if we're doing a count on our product side, we have 2 nitrogens, we have 2 hydrogens, and we have 1 oxygen. Okay, so the first thing that I'm going to try and do is I'm going to try and balance the hydrogens. Now I have 3 on the reactant side, and I have 2 on the product side. So the only thing that I can do is just add another ammonia, so NH3, and that gives me 6 hydrogens. Now the only way that I can balance that on the product side is if I add 3 water molecules, right? So now our hydrogens are 6 of each on each side. And now I'm going to start balancing my oxygens. Now I see that I'm missing an oxygen because I have 3 oxygens on the product side, 2 oxygens on the reactant side, so I have to add another NO2. Now I have my extra oxygen, but now I have a problem where I have 4 oxygens on my reactant side, and I have 3 oxygens on my product side. So the only way that I can do that is add more oxygen on my product side, which is actually going to be just adding another water. So if I add another water molecule, my number of oxygens now become 4, and now, as you can already expect, my number of hydrogens is now changing from 6 to 8. So the only way that I can do this is add some more NH3 to get my more hydrogens. But if I'm adding another molecule of NH3, I get 9. 8 and 9, they're even and odd, so the only way that I can do is add another molecule that's going to give me a total of 12. So now I have 12 hydrogens on my reactant side, so that means I'm going to have to add more water on my product side. So 2 more water molecules, that gives me 12 hydrogens, and now my oxygens is going to be 6. Well, I only have 4 on my reactant side, so I'm just going to add another NO2, that gives me 6. Okay, so if I'm looking at this right now, my hydrogens are balanced 12 apiece, my oxygens are balanced 6 apiece. Now I'm going to be looking at my nitrogens. So on my reactant side, I'm going to start counting my nitrogens. So I have 1, 2, 3, 4, 5, 6, 7 on my reactant side, and I have 2 on my product side. Now, this is where we get a problem, because 7 nitrogens on this side, there is no number that when you times by 2 gives you 7. So this is where you need to deal with the closest even number that I can times by 2 by 7 is I need to deal with a number of 14 nitrogens. Now the only way that I can do that is if I, you've guessed it, multiply everything here by 2, which means I need to multiply all of this by 2. So if I'm looking at it, I have this. I multiply everything by 2, which now gives me 24 hydrogens, 12 oxygens on my reactant side, 24 hydrogens and 12 oxygens on my product side. And if I'm starting to look at this, I now have 14 nitrogens on my reactant side, and I can easily now get 14 nitrogens on my product side by, as you think about it, adding my nitrogen. So now this turns into 14. So now let's actually count the number of molecules I have to figure out my coefficients. And if I'm looking at my NH3, I have the following: 1, 2, 3, 4, 5, 6, 7, 8 NH3s on my reactant side. If I'm looking at my NO2s, I have 1, 2, 3, 4, 5, 6 NO2s on my reactant side. If I'm looking at my N2s, I have 1, 2, 3, 4, 5, 6, 7 N2s on my product side. And if I'm looking at my waters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 waters on my product side. So the reason why I have to double everything is because when I balance my hydrogens and my oxygens, I realize that I have 7 nitrogens on my reactant side, and there is no number that if I times by 2 will give me 7. So in this situation, I have to double everything so I can deal with 14 nitrogens on both sides.